All right, in this video, we're going to start talking about sex-linked traits. So we've covered some of the non-Mendelian inheritance patterns, things like incomplete dominance and codominance, multiple alleles, and the last one that we're going to talk about is sex-linked traits. So a sex-linked trait is a trait where the alleles are on the sex chromosomes. And we talked about in previous chapters the difference between the autosomes and the sex chromosomes. So in humans, we have 22 pairs of autosomes, and then the last pair is special because it is the sex chromosomes. So let's just do a quick review of that. We've got our sex chromosomes. We've got females have two X chromosomes, and males have an X and a Y. So we're going to see that when the traits are on these chromosomes, it changes things a bit. And what you'll see to the right here is a picture of the Russian royal family, the last Russian royal family, the Romanovs. So here we see Tsar Nicholas and the, where's the Tsarina? The Tsarina. They had 4 daughters and they had 1 son. And most of the time when we talk about sex-linked traits, this family comes up because it was very, very impacted by a sex-linked disease. So some examples of sex-linked traits, and in this case, we're talking about abnormalities or diseases, are hemophilia and color blindness. So in the next video, we'll do some practice problems with color blindness. But why do we talk about hemophilia when we talk about sex-linked traits? Well, there's a really interesting and rather sad intersection between history and science. In the 1900s, there was unrest among the Russian people with the Tsar. They called their king the Tsar. And they had only the males could inherit. And this dynasty had existed for like hundreds of years. So they finally had a son. They had 4 daughters and they finally had a son. Well, the son had hemophilia. And in hemophilia, your blood does not clot. It will you'll continue to bleed and you can die from bleeding. It's called the bleeding disease. So because he was such an important piece of the family, the Tsarina was very concerned. And so she became involved with a healer named Rasputin. The guy was kind of crazy, and the Russian people really didn't like him. So because he had hemophilia, she became associated with Rasputin. Because she was associated with Rasputin and the people hated him, it led to even greater unrest in the Russian population. And eventually they were overthrown. And tragically, the rebels at one point took the family and they were all killed. They were shot. But a large part of that came back to hemophilia. So these things matter. So when we're talking about them in genetics, what are we going to do? Well, we're going to use our XX and our XY as our base, kind of like we did with multiple alleles. And we're going to put our allele traits here in exponents. And you'll notice that I did not put a box next to the Y. And that's because for sex-linked traits, these traits are carried on only the X chromosome. Only the X chromosome. And that has some interesting ramifications. So let's say that we have, let's use capital H as normal. And let's use lowercase h as hemophilia. Now, the Tsarina had an allele. So let's kind of draw a map too. So here are mom's, the Tsarina's chromosomes. She has 2 X's. This is an X, this is an X. But the Tsar has an X. And remember, we've got that little Y chromosome. So there's an X and a Y. And the Y chromosome does not have the same alleles. This is the only time we have a mismatch. So what happened was the Tsarina had her 2 X's, and the Tsar had an XY. The Tsar was normal, so he had a normal gene there. But Tsarina had an allele for hemophilia. She was what's called a carrier. So when you have one of the alleles, a recessive allele, this is called being a carrier because you carry the disease, but you do not show it. And this came from her, I think it was her great-grandmother, Queen Victoria. Queen Victoria had 9 children, and they all married into the royal families of Europe. And it was a problem because this recessive allele kept showing up in the royal families, and all of these royal families had troubles with hemophilia. So let's do the Punnett square, and let's see how this shakes out for boys versus girls. So I'm going to do a Punnett square here. We're just doing a 2 by 2. And we'll put, so what you're going to do is you want to write the x's first, or the xy's, and then you're going to add your exponents to represent the disease, and the y does not get one. All right, so let's bring our, pause the video. Why don't you pull your alleles and see what it looks like? All right, did you try that? So you're going to have a homozygous dominant, going to have a heterozygous, so one of the things that's different on sex-linked pedigrees that you can see is that if you look, these are my females and these are my males. So I have a different tendency for inheritance than I do between females and males. So here I have a normal female. Here I have a carrier female. Here I have a normal male. And here I have a male with hemophilia. So for females, we're 50% to 50% normal or carrier. 50-50 normal or carrier. 50-50 normal or carrier, but the males. So for our males, we're 50-50 normal or has the disease. Has hemophilia. And this is what is kind of an issue for men with sex-linked traits because they're carried on the X chromosome. So if I drew it out here, females have 2 copies. So they're kind of protected by the fact that they have to be homozygous recessive to show this disease, but males only have 1 copy. So males only need 1 recessive allele. To exhibit sex-linked diseases. So when it comes to sex-linked diseases, it's not so hot when you're a guy. They tend to have these more. The other ones we're going to look at are things like color blindness. We're also going to look at coat color in cats. So we'll look at some sample problems in the next video. But what are our takeaways? So for sex-linked traits, they're carried only on the X chromosome. And we're going to write those alleles as exponents or superscripts to our XX and our XY. So we see that down here with our Punnett square. And what we see is that females have a much better chance of escaping sex-linked diseases or any traits that are sex-linked versus males, because males only get 1 copy. And that's because this is the only set of chromosomes that is not homologous. It also shows you the power of homologous chromosomes, how it adds protection for us in other scenarios. So, all right, let's practice in the next video.